So landscape waste, the framework, the less energy that needs to go in, the more sustainable, in my opinion. Without waste, cells could not grow because they couldn't push their waste to the perimeter of their membranes, and people do the same thing. All of our solid waste landfills are on the periphery of our cities, and they're getting bigger and bigger and bigger. Innovative solutions will not occur without the acceptance of waste. We can teach people to not make waste. That's great. Maybe they'll make less waste, but they're still going to make waste. Once we acknowledge the fact that we make waste, then I think innovative solutions will follow. We cannot make a wasteless world. Now, I will follow that up with another idea, which is cradle to cradle. Can we control the flow of waste and recycle everything? No. It's a fallacy. You can believe in it, it feels good. But I work in a planning department, the #1 ranked planning department in the world. My graduates go work for the World Bank. I will tell you this, you cannot control everything. Planners can't control the world. There will be things that escape your control. Waste is inevitable. This is Home Depot. Home Depot has a real estate division that buys brownfields. They look for contaminated sites. They can buy them cheaply. What they do in general is they take the contaminated soil, push it underneath where the parking lot will go, cap it, and that becomes a toxic landfill. They build their slab on the clean part of the site. Totally legal. Brownfields legislation allows you to contain, not clean. It's not good enough. I don't think we should do it anymore, and I think we should disclose to the public what's happening. That will lead to better solutions. We've studied big boxes. This is a Wal Mart distribution center outside Phoenix. We did a 3-day project for Dwell magazine. Here's the bottom line. What are we going to do with all the big boxes out there now that they're empty? We took one city that we had already studied, San Antonio. There's 13 Lowe's stores in regional San Antonio. What can you do there? You can do this. You can create 100,000 gallons of biofuel a year called algae-generated biofuel. Easy to do. Technology's there, we know it, the stores are big enough, and more importantly, the stores are connected to infrastructure already in place so that the energy can be transported to where it's needed. What's the biggest waste we have right now? Foreclosures. What are we going to do about that? Well, this is a map showing Atlanta. Foreclosures don't discriminate. Every dot represents 5 foreclosures in a zip code. They're everywhere. The West has 4 of the 5 top states that have foreclosed hundreds, thousands of square miles of foreclosure, if you add it up. What are we going to do with these foreclosures? It's a great opportunity to rethink our suburbs and rethink our cities and do something with a bigger ecological impact near environmental systems that can connect up the new land uses with the old contaminated land uses. Systemic design, thinking in systems, tying things back together, going in to redo what we didn't do well the first time by thinking about how waste can be cleaned and reincorporated into the urban fabric. Now, what I try to focus on is teaching the next generation of planners and designers to reuse waste, not ignore it, not transfer it to another place and time. And essentially, again, I think that's where innovation will occur. This is a project we're doing in Breckenridge. It's almost built. The stats. This was a Superfund site, former mining site. All the gray that you see is mine waste. It's inert. They flipped over the valley where the river was running, essentially mined the gold out back in the 1800s and left this in the valley for the future. Developer bought it, built 200 homes, 250 homes there. There's 2 million cubic yards of waste. We sold it. We resculpted it, and we turned waste into an asset. Now, here's what the EPA normally would do. I work with this amazing guy at EPA Superfund Region 8 named Victor Kateloper. This is the normal solution. You cap the mine, and you put a water treatment plant there. That's what EPA would want to do. We've convinced them to do this. Resculpt, incorporate the waste, make a public landscape, connect the basins where we've resculpted to the river system, get the riparian corridor back in order, let it seed itself, let the fish live, turn it into recreation, and it will manage itself with almost no input of energy or cost. I was fortunate enough to be a fellow at the American Academy in Rome in 2007 and 8. I went to study the Pontine Marshes, which is south of Rome by about 30 miles or so. The Pontine Marshes used to look like this in 1928. Our friend Benito Mussolini came in and drained the whole thing. After 27 previous attempts over 2,000 years, it couldn't be drained. Mussolini came in and drained it in 3 years by bringing in 80,000 people from the north and putting them to hard labor. And they drained the thing successfully, turned it into an agricultural wheat-producing region for his fascist propaganda machine, and pumped the place full of ammonium nitrate and phosphorus, which is how we get most of our food today. This is 1 year difference in growth. I went to Rome to take a sabbatical. I went down to Latina, met with the officials, found out no one had ever actually mapped this. I ended up not taking a sabbatical. We mapped pollution. The largest dots you see are contamination from ammonium nitrate in the water, nutrient plumes running off the agricultural areas into the Mediterranean, directly into the Mediterranean. The whole region is basically the agricultural engine for Rome. The bottom line is that at large scales, you cannot go back in time. You cannot return this back to its original marshland. There's 500,000 people living in here in a massive economy. You cannot erase those. Our proposal was to find the most contaminated aquifer, basically the most contaminated agglomeration of watersheds, put them together, and make a proposal. Our proposal was to build a 2 square kilometer wetland to be able to treat the water, turn it into a park next to the largest city, and connect it all through trails. They had never heard of an artificial wetland before. I met with the president of the province, didn't know what I was talking about, so we had to educate them. We had to tell them our research. We had to show them what we did. And all of a sudden, things started to change. They saw this picture. It had soccer fields in it. They started to buy in. And we just received word, actually, Saturday, I'm going to Latina. We just received word that the Wetland machine received funding from the European Union's Life Plus 2009 program to be constructed. So this will be the first one in a bonifica, in a reclamation area used for agriculture in Italy, and the idea is to repeat this as many times as possible. Went back to MIT after the sabbatical, met with the fluid mechanics lab people, brilliant minds, Heidi Nepf's lab, started to design wetlands, not just an ordinary wetland. This is a dye flow test. And you can see this wetland doesn't work because in the left corner, the water's going backwards. And we studied 3 different types of wetland cells to find out how can we make the most efficient wetland in the world. That was where we started. No one gave us this project. No one gave us a commission for the project. There was no competition for the project. This came from good research. And if there's one message I would like to leave with you today is that designers need to do better research. How do you learn how to do that research? You come to MIT. Thank you.